Je- Jetzt, wir haben Professor Oliver Miller aus Universität Paderborn. Herzlich willkommen. Und jetzt, die Wort ist mit euch.
Vielen Dank, Fabio, für diese Einladung. I will switch to English now because otherwise we have too many languages at the same time. So it's an honor to give this lecture here in the Inter-Uni program. And my talk today will be about the impact of artificial intelligence on our job markets. So in other words, I want to ask the question whether this job will still exist in 20 years. So, of course, if you look back at history, there were always jobs which were disappearing because of technology, and the technology was automating these jobs. If you, for example, think about agriculture 100 years ago and how agriculture looks today. And one question is whether the diffusion of artificial intelligence will also lead to the disappearance of some jobs. Maybe also some other jobs will be created, but some jobs might disappear because an artificial intelligence or robots can do the jobs better than us humans, or maybe also cheaper. I want to start with one example. Already 10 years ago, the University of Oxford, they conducted a study where they developed a website where you can go onto the website and you can enter a job or an occupation, and it will tell you the risk or the probability that this job will be done by a robot in 20 years. So if there's a high probability, then you should better look for a new job. Or if the probability is quite low, you are safe and you can continue your job until retirement. So I can encourage everybody of you to also Google this website. It's from the BBC, from the United Kingdom. And it's titled, "Will a Robot Take Your Job?" And as you can see here, you can enter a job into the search box and then find out about the automation risk, how they call it. And I also did that. My parents always wanted that I become a tax advisor. So people who do, for example, the income tax for other people. We had a neighbor, and he had a really nice house and a big garden, and he was always at home at 5 o'clock. And my mama always said, "Look, that's a good job. You should also specialize in taxes." I, however, found taxes a little bit too boring at that time, and I said, "No, I don't want to have anything to do with taxes." So instead, I became a professor. And then the question is this a good decision of mine? So if you enter, for example, tax specialist here into the search box, you will see that there's a 96% probability that this job will be performed by an artificial intelligence or robot in 20 years. So it is, or you might ask why. Yeah? So what is so special about preparing a tax declaration that it can be automated so easily, obviously? On the other hand, if you look for professor or university teacher here, you will find that the probability of automating this job in 20 years is only 4%. So the probability is much lower. And again, we can ask, so what is it about my job as a teacher or researcher that it's so difficult to automate this via artificial intelligence? And this is kind of the question I want to discuss with you here. And I will show you our study, how we approached this and try to find out about the automation risk of certain jobs. So first, let's look a little bit at the literature. So what is it actually? What are the drivers behind this computerization? As I've said before, why is it so easy to automate preparing a text declaration, but why is it so difficult to automate the job of teaching or doing research? First of all, to analyze this, we have to understand that jobs are a bundle of different tasks. So here you see a picture where we have 3 jobs at the beginning. You can either be a truck driver or a plumber or a software developer. And at the bottom, you see the different tasks or skills which make up this job. For example, a truck driver has to be able to operate a vehicle here, but he also has to be able to have good eyesight so that you can see with low light, and you can also handle different weather conditions. Then you can look at the plumber, and the plumber, if you have to install some plumbing in the basement of a house, you also have to be good in low light vision. But for example, another skill or task you have to master is the installation. Here, the installation of new plumbing, for example. And then you can look at the software developer, and the software developer, of course, needs to be able to program, to write software code. And here, that's maybe a little bit funny. It also says that a software developer has to have the skill of installation. Of course, here installation is quite different. So here, this is more the installation of software and hardware and not of new plumbing. So here you already see a problem that is quite difficult also to describe jobs in terms of tasks, because we have different understanding what a task might be. And maybe the earliest approach to predict what task can be substituted by computers, and especially intelligent systems like artificial intelligence, comes from Autor, Levy, and Murnane from 2003. So what they basically distinguish is here that we have analytic tasks and interactive tasks here at the top, and we have manual tasks here at the bottom. But then we can also distinguish between routine tasks, or tasks which do not change a lot, which are always the same. There is not a lot of creativity involved. And then on the other hand, we have non-routine tasks, which require more knowledge and creativity. And then we can see here, for example, that they predicted that these analytic routine tasks, like calculation or record keeping, for example, there is a high substantial substitution potential. So in other words, this means that sooner or later computers and robots will perform these tasks. On the other hand, if you look at non-routine analytic and interactive tasks, for example, like medical diagnosis, or managing or selling goods and services, or legal writing, they call it that there are strong complementarities. That means here the computer will not replace the human, but maybe they work more together. And at the bottom, we see manual tasks, which are routine. For example, picking and sorting in a warehouse. This is easy to automate. Whereas other non-routine manual tasks, like truck driving, it's very limited opportunities for automation here. So that was a very simple model which they proposed. And I think here, if you look at some examples, we all agree that calculation, for example, should be easy to automate via intelligent technologies, or also picking and sorting. So if you look at a warehouse or a manufacturing plant, for example, in the automotive industry, there is a lot of automation through robots there. What they also predicted is that a task like medical diagnosis, for example, is very difficult to automate. And this, for example, I've highlighted this in red here. I don't agree so much here, because if you look into success stories of artificial intelligence, we have all read on the news that, for example, there are in the radiology department, so where it's about analyzing X-ray images, for example, that artificial intelligence from Google, for example, is better in doing this job than normal doctors. Or we can also look at truck driving, and here we see that the better the self-driving vehicles get, more and more truck driver jobs will probably disappear. This is what I argue. And for example, in the United States, truck driver is one of the most popular jobs in the whole country. There are millions of truck drivers, and companies like Tesla, for example, are working very successfully on replacing the drivers in these vehicles. So maybe this model here from Autor et al. Is a little bit outdated and is not up to date with the very latest machine learning technologies which are available today. Another model which has a similar purpose is from Frey and Osborne, and this is actually the model which is behind the website from the BBC. So what I started with the example where you can go on the website and you can type in a job and get the automation potential. This is actually what the model is doing. So it looks up all the jobs and it decides, for example, how creative is the job. And the higher the job is in terms of creativity, the less likely it is that this job can be computerized. Or on the left-hand side here, you see social intelligence. It says that the more social intelligence you need for a task, the less likely it is that a machine can do it. For example, here, event planning or public relations in comparison to a dishwasher, for example. And on the right-hand side, we see perception and manipulation. So this is basically how good do you have to be with your hands. For example, a surgeon, which is operating you, a medical doctor, has to be very precise with the hands in order to perform an operation. And this is still very hard to automate. Whereas if your job is completely in the digital world, like telemarketing, where you basically sit in front of a computer and a telephone, this is of course easier to automate because there is no human body involved in here. So again, I see a lot of examples where I agree. A court clerk, for example, so that is the person who sits in the court when there is a trial, and he or she is transcribing simply what is being said in the court. So basically creating a report about what happened in the court, and modern audio processing, machine learning technology can easily automate this and can transcribe spoken speech to written text. Then we have a fashion designer here, and I think at the first look, everyone would agree, oh yeah, that's very creative. And this is probably very hard to support or replace with artificial intelligence. However, then I quickly Googled that, fashion and artificial intelligence, and you will find lots of articles which are describing that artificial intelligence is kind of revolutionizing the fashion industry. So that is really clothes you and me are wearing. More and more of this clothing is being designed by computers, completely automated by artificial intelligence. So obviously here also the model of Frey and Osborne, which is almost now 10 years old, is maybe also a little bit wrong, and that the technology which we have in artificial intelligence is now capable of things which we have not thought about 10 years ago. And my last final model, which I want to present here, which is also the newest one from 2017 and 18, is the model by Brynjolfsson and Mitchell and Rock. And what they did is they really explicitly focused on machine learning or unsupervised machine learning. So one specific technology, how we can implement artificial intelligence. And what is special about this technology is that we do not have to pre-program how the computer solves a specific task, but that the computer learns by examples. So we can feed in a lot of good examples to the machine, and the machine will then learn the rules how to perform a specific task itself. I think we have many examples of this also in our normal life. If you think, for example, about children and how children learn their native language. So, for example, German here, I have two young children, 1 and 4 years old, and the 1-year-old child is learning to speak at the moment. How do I teach him? I don't explain the rules of the German language and all the grammar and spelling. Of course not. I just talk to him, and he listens also to other like radio, TV, or when we read out a book. And so what happens is that you present the child with a lot of positive, good, correct examples of how to formulate a sentence in German. And after having heard millions of these examples, the child has learned to produce or to speak itself without learning a single rule. So that also works in human, and that's exactly the idea how a supervised machine learning can be used to train an artificial intelligence. And Brynjolfsson and Mitchell, they came up here with a list of requirements which have to be fulfilled so that this logic can work. I don't want to go through all of them here, but you see some which are highlighted. So what I've explained earlier is that actually the child or the machine is learning a function to translate inputs into outputs, well-defined inputs into well-defined outputs. So if a task or job consists of this kind of work, then it is easier to automate it via supervised machine learning. For example, if you have a doctor and the doctor looks at X-ray images, for example, of a, I don't know, broken leg, or maybe also tumors, cancer tumors, and the whole job is in identifying whether something is broken and to identify or locate it on the picture. So in other words, to give a diagnosis. And then what happens here is we have a well-defined input, namely the image, an X-ray image, and we have a well-defined output, that's the diagnosis. And we have made great advancement in using machine learning for this kind of medical diagnosis because there are lots of large digital data sets of such examples. So if you go into a large hospital, for example, they will have tens of thousands of X-ray images, and each of these X-ray images is associated with a diagnosis from the past. So this is historical patient records, and we have the images, and we have a diagnosis of what the doctor said, what kind of illness or disease we have. So this is another example of this mapping inputs into outputs. And here we have large digital databases, which we can use to train the artificial intelligence. If it, for example, would all be on paper only, how it unfortunately is in many German hospitals still, then it's much harder to train an artificial intelligence on this. So the digitization of this content is very helpful. And then there are other rules here. For example, also that there is no special physical skills required. So this is the same as that our robots are still not as good in manipulation of the environment as a human is. So what Brynjolfsson and Mitchell have is for each of these requirements, they have a detailed questionnaire, and you have to answer lots of questions about a certain job and the task of a job, and then you can kind of calculate a score. They call it the SML score, the suitability for machine learning score. And you see results of an empirical study they did here on the right-hand side. So, for example, a job with a low SML score is massage therapist. So someone giving you a massage. So in other words, this means this is very hard to automate with an artificial intelligence or robot. Most customers would not like it. Or we see another very typical example here if you look into the finance industry, and it's about credit authorizer. So that's the person who decides when you apply for a credit for a mortgage for your house, for example, whether you get the money from the bank, whether they lend it to you or not. And this is also a job, or this is a job where the potential for automation is very high, because this is exactly this. We translate an input, so a description about you, your job, your age, income, etc., etc. How much money do you have on your bank account, into an output, and the output is should the bank give you a credit or not. So this is another example where I think that these the results are very good. Another example where it's maybe not so good is here, funeral director. I was a little bit surprised. So I don't know why here this study thinks that this is a job which can be automated very much. I think here maybe this this checklist is maybe missing a little bit the social perspective. I don't think that most people would want to have a robot as a funeral director. Okay, so if you look back, I've shown you 3 different ways of predicting, forecasting whether a job or task will be or is possible to be replaced by an artificial intelligence. But there are some problems with these works. So first of all, there is very little data about this out there. All these studies have used a very outdated sources like the Dictionary of Occupational Titles or ONET. These are basically databases of jobs, and it tells you this job consists of these and these tasks. You can imagine not every job in the world is in this database. Yeah, so they have maybe like 300 or 400 very common jobs like truck driver or nurse or teacher. But if you have some job like, I don't know, a social media influencer or whatever, these very new jobs, they are probably not in this database. Also, the database is very much focused on the United States, and is very good in some industries and not so good in other industries. So that is a problem with using this data for such a study. And then the second point is to really estimate how much a job can be automated. We need manual or human judgment. So people, in this case, and in all the cases which I've shown you, the researchers ask people. Sometimes it was experts, sometimes it was ordinary people. They ask you whether a job requires, for example, creativity or physical skills and so on. And people had to answer on a scale either from 0 to 1 or on a 5-point scale or something like this. So this is, of course, takes a lot of effort and can also be quite subjective. So these are 2 challenges which are still there. And what we did in our team is to develop a new approach. How can we kind of measure whether something can be automated through artificial intelligence? And in a nutshell, our objective is the following. We want to develop an instrument which is able to, you can give it any kind of job. The job must be a description of the tasks of the job. And the output of our system is a number between 0 and 1, and says, yeah, this is very easy to automate and for different time frames. So as you will see later on, it can tell you how likely it is that this task can be already automated in the next 5 years or in the next 10 years or never. Maybe it takes more than 15 years or never. And the idea is that we want to look at websites, online job posting websites. So maybe you know job posting websites like monster.com. That's a very famous international website where you can search online for jobs. And we take this data source for our study because it has high coverage, of course. So it contains all kinds of jobs from all over the world. It's also very fine granular. So each job is in a way unique. So it's not a standardized description, but it's really like what this one company is looking for. And it's also in real time, we say, because these job postings can change every day. So it is really easy or very useful to measure the demand for certain jobs here using such a website. Okay, how do we do that? I will explain it now a couple of times, and it becomes more and more technical each time I explain it. So if you want to draw a very simple diagram or process model about what we want to do, is our input is here on the left-hand side, a job description. So that's basically an advertisement for a specific job, which we will find online on a website. The first thing which we have to do, and we have created machine learning models which can automate this, that we want to extract the tasks which are described in the job. As I've said before, each job is, in our view, a bundle of tasks. So, for example, if you're a teacher, one task could be that you can design new courses, or that you prepare all the content for the course, that you are teaching live in class or via the internet nowadays, like today, and that you are grading exams, etc., etc. So these would be the tasks which make up the job. What we then do is, for each single of these tasks, we classify it. And again, for this, we have also created another machine learning model. And it classify how long it will take until this job can be replaced by artificial intelligence. We do that for all the jobs and for all the tasks which are in our database. And then as a result, we can, of course, we can analyze that, we can aggregate it. So we can put together a job again as a bundle of tasks, and we can, for example, calculate the average automation potential. Now it becomes even more technical. So this is basically the same pipeline you have seen earlier in 3 phases. So at the top, we have our data acquisition pipeline. So we have created a web crawler, and the web crawler goes onto this website, monster.com. We can give a couple of keywords to the web crawler, and the web crawler will then download all the job advertisement it finds in a database here in this job ads database. We take a subset of these job advertisements, and we have asked people, crowdsources. So we went to a website, Amazon Mechanical Turk, where you can pay people to perform very simple tasks. So we tell them, and I will show you an example later on, here's a job advertisement. Can you please highlight with the mouse and the cursor, where are the tasks in this? Why is this needed at all? You know, a job advertisement contains out of a lot of text. There's also text, for example, about the company and the description of the company. We are not so much interested in that. We are interested in the tasks which have to be performed. And there's, in almost all job advertisements, there is a part where these tasks are listed, for example, as bullet points or so. So we also save these. So we extract the task and we save it in another database. And then the last step in this first phase of data acquisition is that we ask, again, people, for each of the tasks, or for a subset of all these tasks, we ask people to estimate how long it will take until an artificial intelligence can perform this job, or this task, to be more precise. And here we have asked different people. We have asked, again, normal people, crowdsources from Amazon Mechanical Turk website, but we have also asked experts. That means professors and PhD students in business IT discipline. So, and the results of this were also, we again saved in a database. Okay, why have we done this? This is not the result of our study. This is just training data to train an artificial intelligence system, a machine learning model. So we are not, what we have done is we trained a couple of machine learning models. I will show you some details on one of the following pages to automate this. So in a way, if you want, we use machine learning to explain or predict how much machine learning can do in the future. So to automate this task of extracting task out of a free text job advertisement, and we also trained models to automate or to learn to classify tasks according to their AI potential. Once we have these models trained, we can of course feed it with new data. So we can then basically download any kind of job or enter any type of task and give it to the model, and it will output for us how long it will take until this can be used, can be done by AI. And then comes the last phase, explanations and analysis, where we present the results. So we aggregate and visualize the results, and I will show you that also in a second. So a little bit about the details about our data. As I've said, we went to monster.com, a website. I think it's the largest job website in the world. We downloaded 12,000 jobs from the category business operations. So this is, here you see some examples. It's quite a diverse category. It contains a lot of tasks and jobs which are you used to run a business, daily business. And we not only have the textual description of these jobs, but also metadata. For example, what is the category of the job, the title, at which company, in which location, what is the salary, education, and required experience. All these jobs were from the United States. Then came the second task where we asked people to identify tasks. So here you see a screenshot from the system we developed. So people could basically go with the mouse over the text and then kind of highlight sentences which they think are describing tasks of this job. We did this for roughly 10% of our data, so roughly 1,200 job advertisements. And here you can see on the top, typically a job contains about on average 10 tasks. Some jobs contain less, but some also contain many more tasks. And the second manual step in our analysis was rating or classifying these jobs. So what was done here, as I've explained earlier, now we show a specific task. So only one task, you see only one highlighted in yellow here. We also show a little bit of context. So we show a couple of words and sentences before and after the task. We also showed the people what was the title of the job. So here the task is helping to support successful meetings, events, sales training, and special projects. And this is a task of a sales development and event coordinator. And then we ask multiple experts and amateurs to say, okay, can an artificial intelligence do this? If yes, how long will it take? Within the next 5 years, 5 to 10 years, or 10 or more years? And more also includes never. So of course here we are asking for some kind of a subjective assessment. And we kind of brief the people beforehand by all the literature about this question, the literature which I have explained to you earlier on. And we collected lots of these estimates from people. And what our hope is now that when we train our machine learning model on this, that the machine learning model learns when there are certain words appearing that this means that it's a high potential or low potential for automation. So you can think, for example, that training, for example, is something which is quite demanding and challenging, so it will probably take very long. So if you would ask me here, in this, I would probably here click on long term and say, oh, this is a difficult task to automate through an artificial intelligence. It looks like it really requires a lot of coordination, creativity to create organize such meetings and events. So I don't think that an artificial intelligence is really good in this, and I would click on long term. And then again, we collected for 2,500 tasks. We collected such estimates. Now comes the actual machine learning part. So we use these 2,500 estimates or judgments from humans to train a so-called natural language processing model. So this is one type of machine learning which is specialized in understanding natural language as good as possible. Of course, it's not yet as good as humans are in this, but it's quite good already. So this is a deep learning model, and to train this model, we went through a couple of steps. So first, we really feed it. We trained the model to speak English, if you want, or to understand English. So for that, the model was what we call pre-trained by reading the whole Wikipedia and book corpus, which is a collection of 11,000 books. So at this stage, the model learns, for example, what are English words, what is the typical order of words in the English language. So if you want a little bit of grammar and so on, maybe also which words are used in the same sentences or contexts, and might be something like synonyms, etc. Because the vocabulary of job advertisements is quite unique and different from Wikipedia, we also did such a pre-training by feeding another 10,000 job advertisements into the model. So in this case, then the model was really already a little bit specialized in knowing what words appear very often in job advertisements, and that these are words which maybe don't appear so much in Wikipedia, for example. And then as the last step, and that's called fine-tuning, only now we showed to the model the 2,500 training examples. So these training examples consist of a task and a description of a task in English, and what other humans said or think how long it will take until this task can be automated by AI. And by feeding these 2,500 examples through this model, the model learns to associate the appearance of certain words with the judgments, whether it will take long or short. So the model, I don't want to go into the details here. The model we used is called BERT. That's a model which has been developed by Google. It's a transformer model. It's very good in understanding natural language, and especially also in knowing about like the relationship between words, which words are similar, and also very good in considering the sequence of words. So for example, we feed it here with a word at the bottom, with a phrase which is representing a task. For example, clean the dishes. This is not a task which was in our library, of course, but yeah, this could be a task. And then here it learns the output. This is the only thing which you really have to understand. The input is a whole sentence describing a task, and the output is here a probability distribution. So in this case, the model thinks it's 80% sure that it will take a long time until an artificial intelligence can clean the dishes. So that is the output. And in this case, we would say, okay, this task takes a long time, and we repeat this for all the tasks in our database. And then it learns to predict this for unknown tasks. Yeah? So how good is our model in doing that? So the best model which we trained a lot of models, is this one here, BERT job ads. So it's kind of, it was right in a roughly 70% of the cases. So it's the decision, a three-way decision. So it can either, if it would guess randomly, then it would just be right in 33% of the cases. Now we are right here in 70% of the cases. Here you see also that what kinds of mistakes it sometimes takes. So you see on this axis what the model predicts. So often the model predicted, for example, that a task can already be performed by an AI in the short term, so in the next 5 years. And here you see for the same task what the people think. And it's 46. So 46 times our model says it takes only short time, but the people say it takes medium time. So maybe our model is a little bit over optimistic in this case. What is good to see, of course, that there's a lot of agreement here along the diagonal. So for 76 cases, they agreed here. For 130 cases, they agreed here. And for 107, they agreed here. So yeah, to summarize, of course, it's not a perfect predictive accuracy, but it's quite good. And you also have to remember this is quite a difficult task. Okay. So the result of this exercise is that we now also have a model. We have a website, and I want to show you also our website here, where you can just enter a task and you get a prediction how long it will take. So for example, you can say negotiate contracts with customer, and our model says, oh, this will take 10 or more years until an artificial intelligence can do it. And you see also the confidence of the model here. So I hope it works when I now go over here. Yeah, I hope you can see here this website. This is actually the website where I can enter a task and I can write something here, translate from German to English. So as you might know, if you have ever used modern machine translation tools, by now they are quite good in translating, Google Translate, for example. So depending, of course, a little bit on the language, but German and English is quite good to the translation. And I can click on execute, the classification is done. And also here it says our model is super confident that in the short term, within the next 5 years, such a translation, artificial intelligence is as good as humans. But I can also input other things like, for example, maybe something which is a little bit more human, motivate team members. So imagine you are IT project manager, you have to motivate the members of your team. This is maybe a little bit more difficult for a machine to do. And you also see here that it says, oh, this will take a long time. We can also have some fun here and enter something like clean the dishes. Let's see what it will say here. It says it will take long or medium term. But of course, by clean the dishes here, I don't mean a dishwasher, but really like having a robot standing in your kitchen and cleaning the dishes by hand if you want, without destroying it. And this seems to be still a very difficult task. Okay, so now that we have the system, we can do lots of interesting things with it. So this is about the findings of our study. So we used our system and we feeded all the jobs and all the tasks which we have downloaded through the model and calculate the average for here. How long will it take? So it says here, the green here, it says if you say like a little bit more than 25% of the task, the job task, according to our prediction, can already be performed by artificial intelligence within the next 5 years. And then here, on the other hand, if you focus on from today until 10 years, so within the next 10 years, the share here of yes is, of course, much larger. I would say it's roughly, I don't know, 65% maybe. So according to our model, our predictions, within 65% of the job tasks in this category, business operations, can be performed by AI over a time horizon of the next 10 years. That sounds a little bit scary, doesn't it? So what is left for us humans then? First, we thought it's maybe a bit over-optimistic, but if you look at other studies, for example, the study by Frey and Osborne, which I mentioned in the beginning today, this study is almost 10 years ago, and they made a prediction for the next 20 years, and they came to a number of 47%. Yeah. So if you also consider the great advancements which we made in machine learning over the last 10 years, I think our 65% are actually not so far off here. We can also look into, of course, what jobs are can easily be automated. So here over the next 5 years, I've sorted this table by this column here, and it says purchasing assistants, insurance agents, credit analysts, etc., auto damage appraiser. These are all jobs where a lot of the tasks of these jobs can now already be performed by machine learning. And I think this makes a lot of sense because, for example, credit analysis, insurance work, especially deciding how much damage is at a car and how much you want to pay the customers. These are actually tasks which are already today performed by algorithm pretty much, especially credit analyst. No bank gives out a credit based on a human judgment. Vice versa, if I sort by this column, so for which jobs will it take the longest time, or maybe we will never reach it, 10 plus years. And here you see other tasks like business consulting, marketing, and business analysis. So these are, of course, jobs which require a lot of more human judgment and creativity, where it will take quite a long time. And already then it's only 40% here. Another analysis which is interesting is, of course, to look at education. Yeah, we are at the university after all. So does it pay off to go to university? Yes, according to this picture here. So every blue dot you see here is a task in a job. And we see here, of course, for jobs which only require a high school diploma, there is a lot of tasks which have a high automation probability. And then you can basically see how it goes down. So if you have a master's degree, most of the tasks of these jobs which require a master's degree have a very low potential. So in this case, you can say it pays off to go to university, and it's more difficult to replace you by a robot then. We can also look at the years of experience. You see 0 years of experience required versus 12 years of experience required. There is a slight negative trend. So the more years of experience are required for a job, the less likely is it that it can be automated by AI in the short term. However, the trend is really only small. Like you see here that, for example, here, this is where 10 years of experience are required. There are actually a lot of jobs here which can be automated, although they require so much experience. And vice versa. Also, there are a lot of jobs here where you do not require any experience, but they are difficult to automate. So here the pattern, I would say, is not that clear. And finally, looking at the salary, here the trend is more clear. The higher the salary, the less likely is it that the job can be automated. So that, of course, probably correlates very much with the education also. So I think these results all make quite some sense. And the final question which remains is, so what is it actually about a task? So why are some of the tasks easy to interpret and some are more difficult to interpret? So here I would say, here you see words which were appearing in these task descriptions. And if you look at here the short term, 0 to 5 years, there's a lot of words which are somehow about data processing. Reading, measurement, for example, logging, translation, files. It's a lot of administrative work, which is easy to automate in the short term. If we look at the medium term, I would say that here we see a lot of tasks which are a little bit more research and development. For example, design, sampling, analyzing, predicting, and so on. And also some which is about human resources, like negotiation, executives, and education. And if you look at the long term, most of these words are really about interpersonal relationships, inspiring, collaboration, experts, initiatives. So this is really about maybe like leading a team and motivating people, building partnerships with customers and suppliers, and so sitting in committees. So where it's really about human to human relationship and interaction. Okay, I'm coming close to the end. So what is the outlook? So what I've shown you today is a way to predict which jobs and tasks might be replaced by artificial intelligence in the future. Why is this important? This is important for, I mean, everybody now, because it might influence your job choice. So it's also important for universities and schools, of course, because we might have to adapt our curricula to this. And it could of course, also important for companies and even for governments, for political policy making. So, yeah. So how does the future look like is then my last question. So we can be positive and negative about the future. I think the positive or the optimist perspective is that there was always the case that there was a new technology and some types of jobs disappeared. Then other jobs emerge. For example, when the automobile was introduced here, it replaced the travel by horse. And of course, lots of, I don't know, professional horse drivers lost their job. But on the other hand, a whole new industry about around roads, gas station models, etc., emerged. Yeah? It's just a shift. So this is not static, and maybe in the future, in 50 years, our children will do different jobs. I think that is the optimist perspective. However, there are also some people who say, okay, maybe it's different today. So this is different than the steam engine or the automotive. Maybe artificial intelligence is different because it suddenly now can also replace jobs which are more knowledge work jobs, which are not about really hard physical work, but more about cognitive work. And it is questionable whether we can find new jobs for all these people who might run into unemployment. So if you look at Frey and Osborne, they said 47%. Bowles for the European Union said up to 60%, and also our study said 65%. So it's really questionable of whether everyone will find a job, and we might have to ask ourselves whether in the future we all maybe work in a different way, less maybe, or we all have our robot who goes to work for us, and we can stay at home and read a book and enjoy the day. Okay, so this is the end of my lecture. It was a pleasure. I hope that you also enjoyed it. In case you found this interesting and you might have any questions, so don't hesitate to write me an email. We are currently also in the process of writing a paper about this, which will be maybe published next year, and we can also send it to you. Thank you very much, and bye-bye.
Oliver, vielen Dank.
So, hat alles geklappt?
Alles geklappt.
Super, danke.
Und das nächste Mal, ich hoffe, dass du mit euch werden sein.
Ja, genau. Nächstes Jahr vielleicht auch. Wenn meine Kinder etwas älter sind, momentan der Kleine ist 1 Jahr alt, und dann kann ich meine Frau so schlecht allein lassen mit den 2 Kindern, weil meine Frau sie ist auch Doktor im Krankenhaus und arbeitet auch. Und es ist wirklich sehr schwer für uns beide momentan mit den 2 Kindern, und beide arbeiten.
Ja, das weiß ich.
Ja, glaube ich, ja.
Okay. Mein Junge jetzt ist fast 18 Jahre alt.
Ja, dann ist es leichter, ne?
Ja.
Aber dann gibt es andere Probleme wahrscheinlich.
Ja. Nächste Monat Er wird die Abitur machen.
Okay, ja.
Er
Dann
will Medizin studieren.
oh, sehr gut, sehr gut. Ich wollte gerade sagen, hoffentlich wählt er den richtigen Job, nicht, dass er durch einen Roboter ersetzt wird.
Wunderbar.
Ja, super. Schön. Dann, ja, war schön, dich zu sehen und bis bald mal wieder.
Okay, ciao.
Tschüss.
Tschüss.